All right, so there were three ways to solve a system of equations. The first way was graphing. It was the prettiest way. It looked nice. Okay, if I'm doing a presentation, there's lots of color. There's a place where they cross. I can point to it. Looks great. Like makes a lot of people feel warm and fuzzy inside. Okay, substitution, not so much fun, but it's better than graphing because you can get an exact answer. The problem with graphing is, what if it crosses in the middle of a box or in the side of a box? You don't know if that's 1.7 or 1.5. You can make a guess, but you don't know exactly. But with substitution, you get an exact answer. Okay, it doesn't matter if it's a decimal or if it's a fraction. You get the exact answer every time, and that's what makes substitution better. But the best method and the most useful method is elimination. Now, I'm not going to sit here and tell you I don't use all three. I do. Okay? I look at it and I say, well, I can do that problem the quickest through graphing or through substitution or elimination. I just find myself using elimination way more than I use anything else, because more often than not, this is what like my equations start to look like. They don't look like y equals mx plus b. Okay? Like somebody's not going to be kind and do that to me. So what does elimination mean? Well, elimination or linear combinations is pretty much this. I want to get rid of a variable. Doesn't matter which variable I get rid of, but I want to get rid of one of them. Now, again, I'm telling you guys this a lot. You want to step back and smell the roses. You want to look at the problem and you kind of want to soak it in. Now, could I eliminate the x's in this problem? Yeah, I could. It's not really going to change my answer. It's going to take a little longer, but it's not going to change anything. Now, up here, I notice, if I take a second, the y's look way easier to get rid of. Agreed? Does everybody see that? Now, why are the y's easier? Well, they're easier because one's plus and one's minus. That's going to be helpful. And then the big thing is, notice they have the same coefficient out front. It happens to be 1. The coefficient of the x's are 3 and 2. That's not bad, but I kind of have to make them both the same number somehow. The y's are already pretty much the same thing. Now, in order to eliminate, I can either add or subtract the equations at this point. All right. So what I'm going to do is this. I am going to box in my y's because that's going to tell me that's what I'm trying to get rid of. And then I'm going to add the two equations. Now, here's the kind of rule I go by. Same, subtract. Opposites, add. Now, what do I mean by this, Chris? Well, this, okay? Do you see how this is plus y and that's minus y? They're opposites, right? So I'm going to add them. Now, if they were both plus y, I would subtract them because they're the same thing, okay? So I'm going to add these two equations together, okay? Just kind of think of like an old school like algebra problem from like 4th grade where they're like, add 123 plus 437, and you're like adding down. That's what I'm doing here. 3x plus 2x is 5x. Y plus negative y, they cancel. They're gone. 3 plus 7 is 10. Well, that's nice, right? There's no y's. I have 5x equals 10. Divide by 5, you got an x equals 2. That's half my answer, right? Now here's where I go from here, Nikki Granlund. I need you to pick an equation. You can pick the top or bottom. Doesn't matter. You're not going to be wrong. Okay, top. I agree with you. I would have picked the top too. Why would I have picked the top? Well, notice I need to find y now. And I have 3x plus y equals 3. Well, the y is positive. That's going to make my life so much easier at the end. I'm not going to have to divide by it. It's going to be simpler to get y by itself in the long run. Now, could I get y by itself in the bottom one? Yeah, but that's going to require me to like, you know, get rid of that 2x, and then I'm going to have to divide by a -1, and it's just more work, and I'm not about that on a nice, cool day in which I believe we should have had a snow day because there was way too much snow. Okay. So I'm going to rewrite the top equation, 3x plus y equals 3. And here's what I'm going to do. I'm going to take what x equals, and I'm going to plug it in. So I'm going to have 3 times 2 plus y equals 3. 6 plus y equals 3. And then I subtract that 6. And I get y equals -3. And I'm done. My answer is 2, -3. See how nice and easy that is in comparison to substitution? It's got all the benefits of substitution, but it's just not as long. Okay? How you feeling on that? Feeling okay? You lying to me? It's okay. I would lie to me too. I'd be like, sure, whatever you say, Harmon. Should have had a snow day. All right. Yeah. That would have been so much better. All right. That's the easy kind of way to eliminate, okay? So the other way we can eliminate is this. Now in B, notice the variables, none of them have the same coefficients, right? Would you agree, Lance? None of them do? Okay. The x's are different, the y's are different. So, Jay.
Yeah.
Jay, which variable do you want to get rid of, x or y?
Y.
I would agree with you. Here's why I want to get rid of the y and not the x in this problem. Now, the x's, 4 and a 3. I have to find a number that both 4 and 3 go into. That's 12, right? All right, so I'd have to multiply the top equation by 3 and the bottom equation by 4 in order to make the x's the same. But Jay noticed, well, hey, the y's look easier to get them like the same. I think we're all in agreement. The y's look easier to deal with. And you're right, because in order to make them the same, I just have to multiply this bottom equation by 5. So what I'm going to do is I'm just going to start out by rewriting this top equation. And then in the bottom equation, I'm just going to multiply the whole thing by 5. Are you writing any of this down or just soaking it in? That's good. So I'm going to do 5 times 3, that's 15. 5 times -y, -5y. And 5 times 7 is 35. Now do you see that the y's are the same? Mike, do you see that they're the same? The y's? So, same subtract. So I'm going to go ahead and box in my y's. And I'm going to subtract these two equations. So that's going to give me 4 minus 15, that's -11. These cancel. 13 minus 35 is -22. And then I do what, Nikki Granlund? And you got x equals 2. Now, I have to get y. Spirit's itchy. All right, I gotta get y. Caitlin, which equation looks easier to get y by itself? Or to just solve for y? The top or the bottom? The bottom. So in the bottom equation, which was 3x minus y equals 7, I'm going to go ahead and I'm going to take this x and I'm going to plug it in. So that gives me 3 times 2 minus y equals 7. So 6 minus y equals 7. And Lance is like, I already got this, Harmon. Right? You got it?
Yeah.
What'd you got? Awesome. So my answer is 2 negative 1. Kailana, how do you feel about this? Overwhelmed? Me too. Overwhelmed. It's better than, talking about the Eagles because they're underwhelming. They're the opposite. You think that's funny, Lance? Because you know it's funny? The Eagles receiving core. That's funny. JJ Arcega Whiteside. Yeah, let's not talk about that. It's a very sad moment. Just like when the Philadelphians threw D batteries at Santa. It happened. Just like this problem. So this problem up here, it's a little bit more complex. First one's very simple. Okay, I just added the two together, or subtracted the two equations, everything went away. The second one, I had to do a little bit more. I had to multiply one equation. The third way to kind of deal with this is, well, now I just can't make a 4 a 3 or a 3 and 8. It doesn't work like that. All right. Now, there's going to be somebody that, says, well, why don't we just do it this way? I'm going to teach you one way, and then I'll talk about doing it another way. But for now, I just want to kind of teach you something that's always going to work for you, Chris. Ready? Which variable do you want to get rid of? X or Y? Doesn't matter. Y. Okay. So we're going to get rid of Y's. All right. So I have to make the Y's the same. So here's how I do it. I'm going to multiply this top equation by 8. Why am I multiplying it by 8? Because that number is 8. Right? See the coefficient in front of the y in the bottom equation? That's 8. That's why they're the same. Bottom equation, I'm going to multiply by 3. Why? Because that's the coefficient in front of the y in the top equation. Do you see that? You could. Okay. So Kailana said, well, why can't I multiply it by -3? You could. It's just going to say, remember what I said, same subtract, opposites add? You would just do the opposite of us because your signs would be slightly different. Okay? So here, I am going to distribute that 8. Now, 8 times 4 is 32. 8 times the -3 is -24. 8 times 25, I believe, is 200. Now I deal with the bottom equation. That gives me -9x. 3 times 8, that's going to be +24. 3 times 10 is 30. Now I notice my y's have the same number in front of it, right? I'm not worried about the signs. Okay, as I told Kyle, I'm not worried about the signs. I can deal with that. That's the easy part. But the numbers are the same. They're both 24. I box it in, and they're opposites. So opposites add. All right, Kailana, if you multiply by -3, you would have done subtraction. 32 plus -9, that's going to be what? 23? These cancel. If they don't cancel, I did something wrong. If that box doesn't cancel, you're doing something wrong. 200 plus 30 is 230. And now I divide. Now I have x equals 10. Now, I look at those original equations and I ask myself, which one should I use? I need to find x. And I kind of got a rule, okay? It's not really a formal rule. It's not going to be in a textbook or something like that. I go with, I pick the equation that has like the smaller number and more positives, okay? I don't like dealing with big numbers. All right, so in this one, I'm kind of leaning towards the top equation because the x's are positive. I like that. I'm not going to divide by a negative. One less chance I have to make a mistake. So I'm going to write 4x minus 3y equals 25. Draw my arrow up to here. 4 that didn't work. Times 10 minus 3y. Wrong color. Losing it. Losing it. Minus 3y equals 25. So I have 40 minus 3y, right, equals 25. So let's see. Subtract that 40. I have negative 3y equals negative 15. Divide by negative 3. Y equals 5. So my answer is 10, 5. And if you wanted, all right, if you wanted, you could always check your work. With these problems, you should always know if you got it right or wrong. Do you know how you can do that, Kaylin? Oh, thank you. Really appreciate you wanting to know. Now, this is how you do it. You can take these numbers and you can plug them in, okay? Do you see how I plugged 10 into that equation? So you can plug in 10 and 5 into that equation. If it balances out, you got the right answer. If it doesn't balance out, you don't have the right answer. So math is one of those like beautiful things in that, you know, in English class, they'll be like, Lance, tell me why the sky's blue. My response is, sky's blue because of the fraction of light. It's what it is. The end of conversation. I'm not writing a paragraph about it, Mrs. Gregg. Conversation's over, okay? In math, okay, it's straight to the choice. Like there is, like, it's right or wrong. You will know if you got it right. You will know if you got it wrong, all right? I don't have to like fluff it up, make it look cool. That's it. All right. All right, we got 2 questions, and then I'm going to give you guys some time to work on your web assignment. Example 2, I want you to work on these 2, A and B, and then I'll give you guys time to work on your web assign, and I'll make sure to get up the other web assign so you can start working on that. Cancel. Weird. For this one?
I got like a, I think that's.
2 times 2 is 4, 2 times 6 is 12, 2 times 3. And the 4 is bigger than the 12 is cancel out.
So what are you left with? If everything cancels, what's left on the right? And what's left on the left? 6 and nothing? Sure about that?
No, it would actually.
If everything cancels out, what's left? And what do you know about 0 equals 0, Lance? Infinite solution. All right, so obviously the complaint for this problem is this, all right? You look at it, I don't know which variable you chose to get rid of, doesn't really matter, okay? I'm gonna choose x, so I wanna make the -2 like a 4, so I'm gonna multiply that top equation by 2. That gives me -4x plus 12y equals 6. And then this bottom equation, I'm just going to rewrite 4x minus 12y equals -6. And then I chose to get rid of the x's. So they are opposites, so I add, they cancel. Then I got 0, because 12y plus -12y is 0 equals 0. 0 equals 0. True or false? It's true. Infinite solutions. Okay? What about B? Ooh, phone call. Hello? Sure. Okay, bye. Lucky you. But you already know, don't you? After this problem, you can go. Ready? So here, for B, Lance, which variable do you want to get rid of? X or Y? Sounds good. So what did you multiply by to get rid of the x's? Okay, Lance said multiply by 2 on the top. That gives me 6x plus 18y equals 16. On the bottom, you said multiply by 3. That gives you 6x plus 18y equals 21. And Lance said, I'm getting rid of the x's, so let's box those in. So they're the same, so I subtract. 18 minus 18 is 0. 16 minus 21 is -5. Well, that's false, right? So it would be no solution. How are we feeling? Not too bad, right? Okay.